So a research company conducts a poll in a particular geographic area, asking adults to imagine a ladder with 10 rungs. Rung 0 represents the worst possible life, and rung 10 represents the best possible life. Respondents are asked what rung they would say they were on. Responses are classified as thriving, standing on rung 7 or higher, expecting to be on rung 8 or higher for 5 years from now. Suffering, standing on rung 4 or lower, expecting to be on rung 4 or lower 5 years from now. Or struggling, not thriving or suffering. From a sample of 1,200 people, results found that 49% of the respondents considering themselves to be thriving. Complete parts A and B below. So it's part A. Calculate the margin of error for the proportion of adults in this particular geographic area who were rated as thriving for a 90% confidence. Okay, so there is a formula for margin of error. It is Z star times the standard deviation of p hat. So we'll do this with the formula, and then I'll show you how to use StatCrunch to do it. So let's first identify n and p hat. So n is the number of individuals sampled, and p hat is that percentage, and we'll often write that as a proportion with decimals. So 0.49. So the standard deviation of p hat is square root p hat times q hat over n. So we run those numbers. So remember, q hat is just 1 minus p hat. So 1 minus 0.49 is 0.51. You run that in the calculator, you get 0.0143. So that's the standard error. We need to make sure our normal conditions are met. So randomization conditions. So we're assuming that the poll, this research organization, actually took a random sample. We often just have to assume that if it's not explicitly stated. The 10% conditions, what does that mean? So the sample has to be less than 10% of the entire population. That certainly makes sense here. This is rarely violated. And then our success failure condition. So what this says is that n times p hat and n times q hat, they have to be bigger than 10. Okay, so we have 1,200 times 0.49 is 588, which is certainly bigger than 10. Similarly, 1,200 times 0.51 is 612, which is bigger than 10. If that's smaller than 10, our conditions or normal conditions could be violated, so you got to be careful. It's not even close, so we're good there. So now our formula here, again, is Z star, which in this case is 1.645. Remember, that's a 90% confidence interval. 1.96 would be 95% confidence interval. Times, so 1.645 times 0.0143, and we get a margin of error of 0.024. So that is sort of the by hand way to do it. There's certainly value in doing that when it's not super hard. So let's go over and see how we can do this on StatCrunch. Okay, so we're going to open StatCrunch up, and we're going to run a confidence interval. So stat, this is proportion, and we have one sample, and we have just summary data. So the number of successes, this is our p hat. So I can see both of these things here. So it's actually 0.49. You can't just put 0.49 in. It needs to be a number. So you can put 0.49 times 1,200. Sometimes, though, if that doesn't come out even, it'll give you an error message. So in the calculator, we're going to get 588. So you can put 588 in here. And the number of observations, that's the total number, which is 1,200. We're doing a confidence interval, and make sure you change that to 90. We are pretty much always going to select this first one, the standard wall. And then press compute. Okay, so there's our confidence interval. Now notice we're not given a margin of error. Notice there's our standard error. We're given the lower limit and upper limit. So we actually have to still compute what that margin of error is. So just recall that margin of error is going to be the width of that interval and then divide that by 2. So I'm going to say 0.51. Let's go out 4 places. 3, 7 minus 0.4663. So That's the entire width, 0.0474, and then divide that by 2 to get your margin of error. 0.0237, which is very close to what we got when we did that by hand. It should take both answers. If it doesn't, let me know and I can override that. Now it does say round to 3 places, so I'm going to change that 0.0237 to 0.024, which I believe is exactly what we got when we did this by hand. 0.024. Okay, so now what would happen, or would the margin of error be larger or smaller for a 99% confidence? Now you could just run the interval again, but let's think about this. So to be 99% confident, I need to sort of widen out my reach so that I can be more certain that the true population is captured by that interval. So it should be larger, appears to be D. And you could always run that. You can go back to StatCrunch. Go up to Options, Edit, and change that to 99. Bring this back in, and we can see my interval all of a sudden got bigger. And I could compute the actual margin of error for that if I wanted to. Okay, so I hope that helps.